Welcome back, my families. Up until now, everything we've built has been about form, pure shape. But this is the moment where the donut stops looking like an object and starts to feel like food. Now, we move into materials and texture. And honestly, this stage matters more than most beginners realize, because this is where we shift from geometry into appearance, from something you can rotate into something you can almost taste. This is where we start understanding why food feels appealing in the first place, how light rolls across a surface, how different materials respond to that light, and how we recreate that same visual behavior inside Blender. All right, let's begin. Go up to the top workspace tabs and switch to Shader Editor. This is where we build and control our materials, before we think about final lighting or world rendering. By default, you'll notice the scene is already lit. That's because Blender is using an HDRI and material preview mode. This light isn't coming from our scene yet. It's just a preview environment so we can clearly see how the material responds. If you'd like, you can switch to a different HDRI from the drop-down at the top of the viewport. These are Blender's built-in preview HDRIs, designed specifically for evaluating materials. Later, you can load your own custom HDRI and fine-tune it to match whatever lighting mood you're building. But for now, this neutral setup is perfect. It lets us focus entirely on building the material itself. Before moving forward, let's clean up the shader editor layout. If you see extra panels open, hover over the divider line, right-click, and choose Join Areas to remove them. Leave yourself with a single clean shader workspace. Now, here's something important. A 3D model without materials is just geometry. It has shape, but no surface behavior. Materials define how light interacts with that surface. They decide whether light reflects softly or sharply, whether it sinks in or spreads across the surface. In other words, materials define how a surface reflects, absorbs, and scatters light. You don't need to memorize the physics behind it. What matters is developing a visual instinct when something feels believable or when it doesn't. So what we're doing now is training that visual instinct. We'll build the soft bread texture of the donut, then the glossy sugar glaze. After that, the chocolate glaze, and finally, the sprinkles. As we go, pay attention to how the surface reacts, how small adjustments can shift realism dramatically. Because realism doesn't come from perfection, it comes from observation. All right, let's start with the donut base. Select the donut base, then click New Material. Blender automatically assigns a principled BSDF shader, and that's exactly what we want. Make sure your material is using principled BSDF. If it isn't, you can switch it from the shader dropdown. The principled shader is designed to handle most real-world materials in a single node. That's why it's industry standard, perfect for building real surfaces. Now focus on the node setup. You'll notice the material settings panel on the right and the node on the left are connected. Any value you adjust in the material properties updates the principled node directly. They're linked. Let's start with base color. Choose a warm yellow-orange tone, not too saturated, not too bright. Think about baked dough, that soft golden tone you see when bread comes out of the oven. That's the direction. This isn't the final look, it's just the foundation. Next, move down to roughness. Roughness controls how tightly light reflects off the surface. Low roughness means sharp reflections, which reads glossy, almost wet. Higher roughness breaks those reflections apart. Light scatters more, and the surface feels matte and organic. For bread, we don't want gloss. We want softness. Set the roughness to around 0.55, right there. That keeps it slightly porous, not dry, not shiny, just natural baked dough. Now adjust specular. Specular controls the overall strength of light reflecting off the surface. Not mirror reflections, just how much light presence the surface has. Set specular to about 0.35. That's enough. We're not trying to make it reflective, we just want a subtle light response. And already, That feels better. A donut base that looks soft, lightly porous, like it's been freshly baked. Next, let's duplicate one more donut. This one will become our glazed donut. Select the donut base, then Shift-select the icing. Press Shift-D to duplicate. Move this new copy slightly to the left, just like that. Shift the original donut a bit to the right. Just make sure they aren't intersecting. Now scale the plate slightly so both donuts sit comfortably. Give them breathing room. All right, select the glaze on the duplicated donut. Go to the Modifier tab. Set the sprinkles density to 0 for now. Then head back to the Material tab. With the glaze object still selected, add a new material. Now, before we start adjusting sliders, let's pause for a moment. And I mean really pause here. Sugar glaze, real sugar glaze, is a little tricky. At first glance, it feels simple. It's thin, slightly translucent, glossy. But the realism doesn't come from surface shine alone. It comes from how light travels through it, how it bends slightly, scatters inside, then reflects back out. This material is less about surface color and much more about transmission and surface response. Now switch to rendered view mode just for a moment. You'll probably notice the donut looks flat, maybe even dull. That can feel confusing at first. Nothing is wrong. Right now, we haven't built a proper lighting environment. The only light in the scene is that single point light. And honestly, it's not doing much. It's too weak and too isolated to describe how this material should behave. Think about sugar glaze in real life. It never exists in isolation. It's surrounded by light. Light from the sky, light bouncing off walls, light reflecting from nearby surfaces. All of that wraps around it. So if we want realism, we need an environment that supports it. Only then can we judge the material accurately. In Material Preview, we're working differently. Material Preview uses an HDRI environment to approximate how the surface reacts. It's not final lighting. It's a controlled preview. It helps us establish base color, roughness, and reflection before we commit to full lighting. And it does that job well. But it's still simplified. It doesn't fully simulate deeper effects like light transmission through glossy surfaces or subsurface scattering in organic materials. Those effects are important for sugar glaze. Without strong light interaction, the material will always feel incomplete. Material Preview behaves closer to Eevee. Fast, responsive, simplified. When it's time to render, Blender gives us two main engines in the render properties, Eevee and Cycles. Eevee is fast. It's ideal for modeling, animation, and interactive material development. That's why most artists begin there. But Eevee doesn't calculate light transport with full physical accuracy. And that's fine. In Eevee, we're not chasing perfect physics. We're balancing realism with performance. So instead of true transmission, we rely on strong specular response, clear coat layering, and roughness variation to sell the illusion. Even if Eevee can't produce a physically perfect glaze, we can still build a convincing foundation. Later, when we switch to Cycles, we'll refine this same material and let real light physics elevate it. That's how production workflows operate. You build something believable first, then you refine it when the renderer allows you to. If the difference between Eevee and Cycles feels abstract right now, don't worry. We'll go deeper into both rendering engines when we reach the lighting and rendering stage. For now, focus on the surface. Alright, back to the glaze. For base color, choose a soft off-white sugar tone, not pure white. Think melted sugar, slightly warm, slightly creamy. Now adjust roughness. A fresh glazed donut has noticeable shine, but it's not glass. Set roughness to around 0.18. That gives us a clean sheen without turning it into plastic. Next, IOR, Index of Refraction. IOR controls how light bends inside the material. For food surfaces, it usually falls between 1.3 and 1.5. Sugar sits around 1.45. Now, adjust specular. Specular controls how strongly the surface responds to reflections. Set specular to about 0.55. Next, clear coat. Think of clear coat as a thin, glossy layer sitting on top of the glaze. Set clear coat to 0.35. This creates that extra reflective layer you often see on real sugar glaze. Then, adjust clear coat roughness to around 0.08. Even that top layer shouldn't be perfectly sharp. Take a look. Even inside Eevee, this is starting to read as sugar glaze. Is it physically perfect? Not yet. But as a base, it's solid and believable. That's exactly where we want to be at this stage. Now let's introduce surface variation. Here's something important. Roughness is never perfectly uniform in real life, especially with sugar glaze. Some areas are slightly wetter, some are a little drier. Some catch sharper highlights, others diffuse them. That subtle inconsistency is what sells realism, particularly in Eevee. Instead of feeding a single value into roughness, we'll break it up. Drag from the roughness input on the principled BSDF node. Add a color ramp node. Then press Shift-A, go to Texture, and add a noise texture. Connect the factor output of the noise texture into the color ramp. Now the color ramp output goes into roughness. What we're doing is controlled variation. Some parts of the glaze will be slightly smoother, others slightly rougher. Now, let's refine that variation. Look at the color ramp. The noise texture creates the pattern of variation. The color ramp controls how strong that variation becomes. Move the black handle to around 0.1. This limits how dark the pattern can get and prevents harsh contrast in the roughness. Move the white handle to around 0.3. Real sugar glaze has very subtle irregularity. We're compressing the range to keep it delicate. Now adjust the noise texture. Set scale to 18. Scale controls the size of the surface variation. If the value is too low, the bumps become large and obvious. If it's too high, the texture starts to look noisy. For glaze, we want fine micro variation. Set detail to 6. Detail increases complexity inside the noise pattern. Too much detail makes it harsh. We just need enough complexity to break the smooth plastic look. Then set noise roughness to about 0.45. This softens the internal contrast of the noise pattern. Now a quick note, especially when working in Eevee. You might be tempted to enable transmission or subsurface scattering. They sound physically correct, and in theory, sugar glaze does involve light passing through the surface. But in Eevee, these features often make the material look less convincing. Instead of adding realism, they make the material appear artificial. So for now, we leave them off. Later, when we switch to cycles, we'll introduce transmission and subsurface properly. Under real light simulation, they'll finally behave the way we expect. Right now, we're building foundation. In production, materials aren't finished in one pass, not because we can't, but because we work in layers. First, a controlled base, then refinement under proper lighting, then physical accuracy where it matters. That's a professional shader workflow, and this approach isn't just about donuts. After this series, you'll build larger scenes, more complex assets, heavier environments. Those projects demand performance and structured thinking. That's why we're using a glazed donut. It looks simple, but it teaches shader control, lighting discipline, production workflow. This is real 3D practice. Trust the process. Later on, you'll understand exactly why we built it this way. Now, let's build the material for the Krispy Kreme chocolate glaze. Select the chocolate glaze first. Temporarily set the sprinkle density to 0. We want to evaluate the surface without distractions. Alright, instead of building this shader from scratch, we're going to take a smarter approach. We'll duplicate the sugar glaze shader. Structurally, it's the same type of material. It's still glaze. It still has a glossy surface layer. The difference isn't in the setup. It's in how the surface responds to light. Press A to select all nodes. A for all, consistent across Blender. Press Ctrl-C to copy the entire node network. We're preserving the structure, we're just recalibrating it. Now switch to the chocolate glaze material. Select all existing nodes and delete them. Press Ctrl-V to paste the copied setup. Now we're working from a familiar base. First, adjust the base color. Choose a rich chocolate brown, not pure black, not too saturated. Pink melted chocolate, deep, warm, slightly soft in tone. Next, adjust roughness. Set it to around 0.22. That keeps the surface glossy, but slightly more controlled than the sugar glaze. Now lower the clear coat value to about 0.25. Sugar glaze reflects light strongly at the surface. Chocolate behaves differently. Chocolate absorbs more light. So instead of relying on heavy surface shine, we let lighting contrast define the form. Darker materials depend more on lighting direction and intensity, and once we introduce proper sunlight, this will respond nicely. Now, adjust the noise texture. Set scale to 6. Chocolate glaze doesn't have fine micro variation. It flows slowly and spreads with weight. When melted chocolate is poured, you don't see small ripples everywhere. Instead, you see broader, smoother variation. Lower scale values give us exactly that kind of surface. Set detail to 2. We keep this intentionally low. Too much detail introduces sharp breakup, and chocolate doesn't fracture that way. Now go to the color ramp. Change the interpolation from linear to ease. Chocolate transitions gradually. It doesn't shift abruptly from glossy to rough. Move the black handle to around 0.35. This reduces how extreme the rough areas become. Move the white handle to about 0.65. This pulls the brighter reflections inward, making them smaller and more focused. With just these adjustments, the material already reads differently. Same structure, different light behavior. Now let's move to the sprinkles. Before continuing, go back to the Modifier tab and restore the sprinkle density on the Krispy Kreme donut. Good. Well, create one shared material for all sprinkles. Select any single sprinkle object. It doesn't matter which one. Create a new material and name it Sprinkles. Right now, only that one sprinkle has the material, and that's correct. Now Shift-select all the other sprinkle objects. This part matters. Make sure the last sprinkle you select is the one that already has the material assigned. It will appear highlighted in yellow. That means it's the active object. Selection order matters here. Press Ctrl-L to open the Link or Transfer Data menu. Choose Materials. Now all sprinkles share the same material, which means one change updates everything. Next, switch to the Geometry Nodes workspace. This is where we'll generate randomized color variation. Press Shift-A, go to Attribute, and add Store Named Attribute. Place it right after the Realize Instances node. Change the type to Color. Change the domain to Instances. For the name field, type something like Sprinkle Color. We're defining an attribute the shader can read later. Now switch to the Shading workspace. Select one sprinkle, any one. Press Shift-A, go to Input, and add an attribute node. In the Attribute Name field, type the exact same name, Sprinkle Color. Take the color output from the attribute node and plug it into the base color of the principled BSDF. Now go back to Geometry Nodes. While you're there, change the viewport shading to Material Preview so we can clearly see the color changes. From the value input of the Store Named Attribute node, drag out and add a color ramp. Drag from the Factor input of the color ramp and add a Random Value node. Set the type to Float. At first, nothing interesting happens. That's because the color ramp is currently blending from black to white. Here's the key adjustment. Change the color ramp interpolation from linear to constant. Now each sprinkle snaps to a single solid color. No gradient blending. That sharp separation is exactly what we want. Click the plus icon to add a new color stop. Choose a soft light blue. Add another stop, maybe a soft red. Slide the ramp handle slightly and watch the distribution shift. Let's add another color, a soft yellow. Keep saturation controlled. Highly saturated colors tend to feel artificial. For something like sprinkles, aim for saturation around 0.8. Finally, add a white sprinkle. The position of each stop controls how much of the surface receives that color. Avoid perfectly even distribution. You might let one or two colors dominate, while others appear more occasionally. That's actually closer to how real sprinkles behave. Usually, one color is more common, another shows up here and there, and a few appear only in small scattered amounts. Let the ramp reflect that imbalance. Now let's finalize the surface behavior. Switch back to the shading workspace. Set roughness to about 0.4. Sprinkles shouldn't be glossy. Their realism comes from variation in color, rotation, and distribution, not from reflection. Set specular to 0.4 as well. Even though Blender allows metallic materials, real sprinkles are sugar, not metal. And that's it. Just by adjusting a few ramp stops, you've created an entire sprinkle color palette. Now, for the ceramic plate, let's assign a material. Select the plate and create a new material. For the base color, choose a neutral gray, not too dark, not too bright. Set roughness to around 0.4. That keeps the surface smooth without turning glossy. Set specular to about 0.4 as well, just enough to catch soft highlights. Then set the coat weight to 0.1. That adds a subtle top layer, helping the ceramic respond more naturally to light. Alright, that works well. Now let's move to the plane and turn it into a marble countertop. First, scale the plane up so it looks like a full countertop surface. Instead of using a flat color, we'll use an image-based marble texture. Image textures introduce real-world micro-detail, natural veins, subtle imperfections. They add a lot of realism with very little setup. Select the plane, add a new material, then open the shader editor. Click the small circle next to base color and choose Image Texture. Right now the surface turns black. That's normal. Blender is waiting for an image file, so next we'll download a texture. Open your browser and search for Free PBR. You can also find the link in the description. Free PBR provides royalty-free PBR materials commonly used in production workflows. Search for marble. Choose a white marble texture. It works best for this scene since we're aiming for a clean kitchen-style countertop. Download the Blender zip version. Once it finishes downloading, unzip the folder. Inside, you'll see multiple high-resolution maps. Some control color, others define roughness and surface detail like normals. We'll start wiring those up next. Now return to Blender. In the Image Texture node, click Open. Navigate to the folder where you extracted the marble files. Select the image that ends with albedo, then click Open. Immediately, the plane updates with detailed marble patterns. It's already an improvement, but notice, it still feels slightly flat. The reflections are too uniform. Real marble doesn't behave that evenly. To fix that, we'll connect the additional maps. Quick reminder, in the shader editor, nodes generally flow from left to right. Image textures provide data. The shader interprets that data, and the shader output becomes the final material on the object. Right now, we've only connected the color map. That's the albedo texture we just loaded. Next, we'll add the roughness map. Drag from the roughness input and add an image texture node. Open the same folder and choose the image with roughness in its name. Once loaded, change the color space from sRGB to non-color. This step matters. Roughness is not color information. It's grayscale data that controls how light scatters. If left in sRGB, the surface will respond incorrectly. Now the marble starts to develop variation. Some areas reflect light more softly, others remain slightly matte. Next, let's add the normal map. Drag from the normal input and add another image texture node. Open the image that contains normal in its name. Just like before, change the color space to non-color data. Normals represent directional data, not color. Press Shift-A, go to Vector, and add a normal map node. Connect the color output from the normal texture into the normal map node. Then connect the normal output into the shader's normal input. Now look at the surface. The marble has subtle bumps. Tiny dents and veins interact with light more naturally. Highlights break across the texture instead of sliding uniformly. Press Ctrl Space to go full screen and evaluate the surface closely. It no longer feels flat. The marble now reads as a solid, physical material. And that's our countertop material. Nice work. Now, let's add a final layer of realism to the donut itself. Go back to the Layout tab and isolate the donut by pressing the / key. This local view helps us focus entirely on the donut surface without distractions from the rest of the scene. Switch to Material Preview so we can clearly evaluate changes as we paint. If you look at real donut references, you'll notice the surface color shifts slightly because of heat and oil absorption, especially around the inner ring and along the outer edges. Those small tonal variations are what make baked food feel believable. This is where texture painting becomes essential. Before we start painting, we need to understand one core concept: UV unwrapping. Texture painting doesn't happen directly on the 3D geometry. Instead, Blender paints onto a flat 2D image. That image is then wrapped around the 3D model using a UV map. UVs are essentially layout instructions. They tell Blender how the flat image attaches to the 3D surface. Think of peeling an orange and laying the peel flat on a table. That flattened peel is your UV map. Every curve and surface section of the donut is assigned a specific area on that flat image, so when you paint on the image, it appears correctly on the 3D model. Alright, switch to the Texture Paint tab. If you try painting right away, you'll notice nothing happens. You may get a warning, missing textures detected. That's expected. UVs define placement, but we haven't created an actual image to paint on yet. Go back to the Material tab. Click the small yellow dot next to Base Color and add an Image Texture node. Instead of opening an image, click New. Name it Donut Base. Choose a resolution high enough to capture fine surface detail. Set the default color to a warm yellow tone that matches baked dough. Then click OK. Make sure this new image is selected in the Image Texture node. This step matters. Now Blender knows exactly where to store your brush strokes. Every mark you paint will be written to this image file. And now we have a canvas for painting subtle color variation into the donut surface. Select the eyedropper tool and sample the donut's current base color. Then adjust that color slightly lighter. Not white, just a subtle lift. We're simulating areas where the dough baked a little more and caught extra heat. Choose a soft brush. Set strength to about 0.5, so strokes blend naturally into the surface. Now you can paint directly on the donut inside the 3D viewport. You'll see the color update immediately on the model. You can also paint inside the image editor over here. Both methods affect the same texture, so you can switch between them at any time. The image editor often gives better precision, especially near the inner ring. Start around the center. Move slowly along the inner edge. Keep the brush close to the inner edge, not too far out. Build it up slowly. You'll already start to see subtle variation forming. If some areas look slightly overpainted, don't worry, we'll blend them. Once the initial strokes are done, switch the brush type from Draw to Soften. Brush over any spots that appear too bright. You'll notice sharp transitions start to smooth out. Let the tool smooth the gradient. We're aiming for subtle variation, no hard edges. For the inner ring, switch to Airbrush. Lower the strength to about 0.2. Now, work in the image editor. Paint over the top corners and wrap the color into the inner ring. Build it gradually. Now switch back to a soft draw brush. Increase strength to about 0.8. This pass is for confident blending. Focus on the edges, smooth all transitions. Unify the surface. There shouldn't be any sharp breaks. Step back for a second and evaluate the result. The donut now has subtle heat variation. It feels baked. That small shift adds a surprising amount of realism. Once you're satisfied, remember, texture painting is not saved automatically. Look at the top left of the image editor. If you see a small asterisk next to the image name, the texture hasn't been saved yet. Go to Image, Save, and choose a location on your drive. This is critical. If you skip this step, all your painted detail will be lost. After saving, press / again to exit local view. Everything returns to the scene. And that completes our texture painting pass. Now, go back to the Layout tab. Before we move on, let's create a backsplash by duplicating the marble plane. Select the countertop. Press Shift-D to duplicate it, and move the copy slightly out of the way. Press or then X to rotate along the X-axis. Hold Ctrl while rotating for precise increments, or type the exact rotation value and press Enter. Now move the duplicated plane upward until its bottom edge aligns perfectly with the back edge of the countertop. And there we have it. The backsplash is in position. Next, select both marble planes and move them up together. Raise them slowly until the countertop sits slightly above the Z-axis. Now select the plate and donuts together. Press G, then Z, and lift them slightly until they rest on top of the countertop. Check the contact point. No floating, no clipping. Good. And that wraps up our materials and textures. At this point, it's worth stepping back and looking at everything together. We approached this scene by modeling first, then assigning materials across the objects. That allowed us to compare surfaces side by side: ceramic, marble, glaze, dough, and observe how each responds to light. In larger production scenes, you might choose a different workflow. Sometimes artists fully model one asset and finish its material before moving on. That approach keeps things modular and easier to manage in complex environments. Here, the goal was clarity. I wanted you to understand how materials, texture maps, and subtle variation work together across a full scene. Once that foundation is clear, you can adapt the workflow to whatever project you're building. And seriously, well done. You've taken this donut from simple geometry to a fully textured scene with layered, responsive materials. In the next part, we'll move into lighting and shading, the stage where everything comes together under real-world light simulation. So when you're ready, join me in the next video. I'll see you there.